Hello, welcome friends. Me Anila. The topic of my discussion is about limiting reagent part 3. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you some more numerical on limiting reagent part 3. Part 1 and part 2 I have already discussed earlier. In this video, I will tell you about part 3. In a chemical reaction, the starting materials are called reactants and the end material is called product. If there are two starting material, one is limiting reagent, other is excess reagent. Limiting reagent means that is producing less moles of product, and excess reagent means which is in excess. So in this video, I will tell you how to identify limiting reagent part 3. Example, these are two-step reaction, two equations. Iron transition metal reacts with sulfur, a non-metal, to form iron sulfide, and iron sulfide reacts with 2 moles of hydrochloric acid to produce ferrous chloride and hydrogen sulfide gas. Now, 28 gram iron reacts with 24 gram sulfur. Excess HCl added later. Find limiting reagent in step 1. Mass of FeS formed. Volume of hydrogen sulfide at STP. So 28 gram iron, mass of iron is given. 24 gram sulfur, mass of sulfur is given. Excess HCl added later. In step 1, we have to find which of them is limiting reagent, either iron or sulfur. The one which is limiting reagent, according to that, the product ferrous sulfide moles is calculated, and from ferrous sulfide moles we will calculate hydrogen sulfide moles, and then volume of hydrogen sulfide at STP means at standard temperature and pressure. Standard temperature is 273 Kelvin or 0 degree centigrade. Standard pressure is 1 atmosphere or 760 torr. Solution. First we want to know the atomic weight of iron, that is 56 gram per mole. Atomic weight of sulfur, a non-metal, 32 gram per mole. Amount of iron and sulfur are given. Atomic weights are given. Now we will calculate moles of iron and sulfur respectively. Moles of iron is equal to 28 grams as already given in the example, divided by 56 gram per mole, that is atomic weight of iron. After solving, moles of iron is calculated to be 0.5 moles. Now moles of sulfur, a non-metal, 24 gram, amount already given in the example, divided by 32 gram per mole, atomic weight of sulfur. After solving, the moles of sulfur is calculated to be 0.75 moles. Now we have calculated moles of iron and sulfur. Since we have to identify the limiting reagent, either iron or either sulfur, so moles of iron sulfur are calculated 0.5 moles, 0.75 moles. Now we will have to detect which of them is limiting reagent. First we will take iron. If iron is limiting reagent, 1 mole iron produces 1 mole ferrous sulfide, as already given in the example that 1 mole iron produces 1 mole ferrous sulfide. So 0.5 moles iron produces, because it is 1:1 mole ratio, so it is 0.5 moles ferrous sulfide. So if iron is limiting reagent, it is producing 0.5 moles ferrous sulfide. Now we will see that what happened with sulfur. If sulfur is limiting reagent, we have to detect 1 mole sulfur produces 1 mole ferrous sulfide as already discussed earlier in the equation step 1. So 0.75 moles sulfur produces 0.75 moles ferrous sulfide because there is also 1:1 ratio. So 0.75 moles sulfur produces 0.75 moles iron sulfide. Because iron is producing zero point 0.5 moles FeS, sulfur is producing 0.75 moles FeS, so iron is producing less moles of product, so it is a limiting reagent. So we have identified the limiting reagent is iron because it is producing less moles of product, that is FeS. Now the part 2 of question, mass of FeS formed. We have to calculate mass of ferrous sulfide formed. For this, first we will calculate molecular weight of FeS is equal to 1 is the number of iron atom into 56 is the atomic weight of iron plus 1 is the number of sulfur atom into 32 is the atomic weight of sulfur. After solving, molecular weight of ferrous sulfide is calculated to be 88 gram per mole. Now, because iron is limiting reagent, so since iron is producing less moles of product, so it is a limiting reagent. Since iron is producing 0.5 moles FeS, so we will calculate mass of FeS is equal to zero point 0.5 moles because 0.5 moles is less than 0.75 moles. Mass of FeS 0.5 mole multiplied by 88 gram per mole, which is the molecular weight of FeS. After solving, mass of FeS is calculated to be 44 grams. So we have calculated mass of FeS form. Now, the part 3, volume of H2S at STP. H2S is a gas. STP means at standard temperature and pressure. Temperature is 273 Kelvin. Pressure is 1 atmosphere. 273 Kelvin is equal to 0 degrees centigrade. 1 atmosphere is equal to 760 torr or 760 millimeter of mercury. In the equation, 1 mole FeS produces 1 mole hydrogen sulfide as given in the step 2 equation. So 0.5 moles FeS that we have calculated earlier produces 0.5 moles H2S because there is 1:1 mole ratio between FeS and H2S. So the moles of H2S are calculated to be 0.5 moles. Now we have to calculate volume of H2S at standard temperature and pressure. For this, as you know that PV is equal to nRT. This is general gas equation. In this equation, N is 1 mole, R value 0.08201 atmosphere decimeter cube mole inverse Kelvin inverse into temperature is 273 Kelvin and pressure is 1 atmosphere. After solving PV is equal to nRT, volume is calculated to be 22.4 liters. So 1 mole of a gas occupies 22.4 liters. So hydrogen sulfide is a gas, it occupies 22.4 liters that we have calculated from general gas equation. So 0.5 moles H2S occupies 22.4 is multiplied by 0.5, we get 11.2 liters. So the volume of H2S at standard temperature and pressure is calculated to be 11.2 liters. So we have calculated limiting reagent, we have calculated mass of product form, we have calculated volume of H2S at standard temperature and pressure. In this way, limiting reagent is identified. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.